name's Geoff. I work at SmugMug and Flickr. I manage our data science and engineering team. Can you hear me? Okay, great. Yeah, okay. Hold a little closer. So today I'm going to talk about AI and machine learning development on AWS. What model should I use? It's kind of motivated by our work doing data app development on AWS tools, particularly SageMaker. And we're trying to use good metrics to decide how to develop these data apps. In particular, from the data science perspective, there's three kinds of models that we need to choose, need to design or choose. Foundation models, right, that huge productivity gain you get from AI these days, choosing those. Choosing predictive machine learning models, your classic regression, time series, clustering. And then probably last but definitely not least would be SQL or SQL models. Kind of how do you extract the data and present it to the other models so that they're effective. So from the data science point of view, all of those are important, we find. And we'll dive into that. I guess the perspective we would take is a technical person we're collaborating with on another team, maybe an app development team or another function, or a new person on our team. What do they need to know to be effective? So again, I work at SmugMug and Flickr. So those are about 20-year-old companies, and our mission is to build a better world through the power of photography. We like to say that we are the favorite web platform of the best photographers in the world. So, and in the case of Flickr, it's a social network, so they will share their great photos and get recognition from their peers. And SmugMug is a commerce platform, so they can sell their photos, digital downloads and things like that, or prints and gifts through our network of print labs. And you may have heard of Flickr in the context of machine learning over the years. So if you go on Hugging Face or other platforms, you'll see attributions to Flickr photos that have been used to train models. And we were a pioneer in the Creative Commons license, so our photographers can allow their photos to be used for purposes like that. We just ask that folks don't scrape, that they look for the photos that have the Creative Commons license. Okay, then kind of back to where I'm coming from. So the companies are organized differently. In our team, we are the cloud data warehouse team and the data science team. And I remember in reInvent last year, Werner Vogels had a great joke. It was the first part of his keynote talk, where the data science team is the team that comes and crashes the company's databases. And our company solved that by making us in charge of the OLAP database. So we're crashing our own tools if we go crazy. But in all seriousness, it's a big task to kind of manage all of the company's data in this way. And we've got a lot of tools that we're using for data discovery, and then cleaning up the data, orchestrating it, and providing good data out to these other tools, like the SageMaker, Bedrock, Amazon Q, and these very special purpose BI tools that people use. And then if the app needs a specific type of data science output, we can provide that. Okay, so for choosing models, let's start with the AI foundation models. I thought we'd try to choose one that is interesting visually. So I know your phone, right, can probably sort photos really amazingly, and it's getting better and better. But I think every app will still need to sort and surface things in its own special way for its purpose. And you'll find that here, right? So, and it depends on the query type. What you're asking for is in how you're going to return the data in an organized way. Imagine query one. These are all football players, because on our platform, we have a lot of sellers who are maybe their high school's licensed photographer that goes out and takes 1,000 pictures of Friday night's football game. And this is football season. But then how do you find the photos you care about out of all that? If you have a more aesthetic style query, that's the top one. You're looking at sky, you're looking at, you want to include some of the stadium or something. And then you're going to match the two photos you see there on that top row, Sky 1 and Sky 8. If you have a different type of query, maybe you want to buy a commemorative photo for your son, your nephew, your grandson, you're going to look for a jersey number, like 1. And so Sky 1, Grass 1 would be the best choices. So now, as a machine learning engineer, data engineer, an engineer of some kind, you're tasked with building out this service. and you have a lot of choices. So Amazon Bedrock would be a place to go to look for these. If you look on Amazon services, you can string together a lot of things that would probably work, but some are better than others, right? So for the top query, you're looking at recognition tags, AWS recognition. Maybe you'll get 20 labels of what's in the photo, and then we can give it to a multimodal embedding model that also looks at the pixels. So you're looking at some text descriptions and some pixels, and you're getting a great result out. You get the right photos. But for some things, how do you weight that? How do you weight the text versus pixels? It's kind of a black box, and it's not fully under your control. Another option would be Claude Sonnet text description. That gives you a very detailed, up to 8,000, basically 8,000 word kind of description of what's in the photo, including the numbers and other kinds of details. And you can get something like the exact jersey number independent of what the background looks like. So these are the types of application-specific questions that come up. And then you have all the others, like what is the cost, what is the time for the specific model to process this and score it and such. But you can get different outcomes based on your different choices, and you need to kind of rationalize that. Now, from the data science perspective, what we noticed is you've got these pairs of things that have been scored, and you have the cosine similarity scores. You have their rankings. That's all available to you, so you can start doing your own app-specific metrics to judge quality. So just to recap some classic data science approaches that are pretty easy to roll out, you could have some categories for which you expect these to be clustered nicely, and you can run k-means or something and look at the clusters. You can do a kind of a confusion matrix approach, true positives, true negatives, false negatives, and do metrics on that. Specific ranking metrics like Kendall's tau. And then you can also start at the target image in this case and do distributions of the similarity scores. And then you can kind of do moments of the distribution, your means, median, standard, and skew, kind of compare that, and that becomes a quality metric. Or you can do ratios of all of these. So that is something that you can do directly with the output of FMs. But now we get to kind of where the state of the art is. We find LangChain is a great, it's evolved over the last couple of years to be a great kind of Swiss Army knife in this area. And they have their own evaluators. You can call types of services with that framework, and they have their evaluators. Tend to focus on strings, and text stuff. Another one we just became familiar with and we're excited about is Ragus metrics. There's a link to the website and also a blog where the founder talks about how this developed. But it's specific for different types of foundation model analytics. And in particular, they had things like conciseness score for summarization, things that you don't get off the shelf from other domains. And last but not least, from the management perspective, if we're asked, are we spending time on the right things? Should we be spending all this time on these? But yeah, the top minds in the field are like, yeah, now's the time. You should be doing your own app-specific benchmarking for how all this stuff works. So that would be what I would share with a collaborator or a new person on my team about this subject. Let's turn a little bit to classic machine learning. This is really interesting. We've seen our business partners now know a little bit about this space and then start to dump data samples into OpenAI, ChatGPT, and it'll write a machine learning model for them. And I think even now it has the sidecars where it'll compute some results. And that's great. I mean, that handles some great machine learning use cases. But for the heavy-duty stuff, we still need real tools like SageMaker. And the thing that really interests me is AutoML in this space. So we've had a team of experts build a CatBoost model. That's a type of XGBoost, kind of a predictive regression model. It got decent results. But we put the same thing against AutoML. And in SageMaker, you can try Canvas or SageMaker Autopilot. The model metrics, the classic model metrics, are pretty equivalent across the two. But AutoML made really efficient use of the inputs. And that was surprising. It's just, I think the benefit of this is AutoML is going to do things you didn't expect and maybe find new ways of doing things that you didn't anticipate for using the model inputs in an efficient way. And that actually has importance for managing a data warehouse because, wow, maybe we don't have to put data engineering time on maintaining the inputs that are not so important. So yeah, really interesting field is AutoML here. But maybe most important for data science, in my perspective, having worked in it in the last few years, is kind of SQL development and data modeling. It's not the most glamorous thing, but it's the most difficult thing from the perspective of a data warehouse because the data sets we're bringing in are from so many different sources. And a lot of times the tables that we have in there are meeting each other for the first time. And maybe the people who designed them have moved on, there's no documentation. We have to figure out the grain, the cardinality, the join keys, all that kind of stuff. And literally, I kid you not, it's taken years to do that correctly for some of the most difficult projects. It can take years. So what we did, with the help of AWS ProServe, and I would like to thank Srinivas Siddiqui and Will Matos for their great help here, is we built a RAG, a retrieval augmented generation flow that takes all the artifacts that we need to kind of understand the data and provides it to Amazon Q. And again, you'll see a lot of great text-to-SQL models, a lot of cool data modeling AI solutions coming out. I think Amazon Q has a special place, though, for reasons I'll describe in a moment, but also because, AWS is our premier data engineering vendor, and we want to grow with them, and we're hoping that Amazon Q can really develop. So as I mentioned, one of our key problems is joining those tables, but also like making sense of where all the relevant data is. So we don't have like PHP experts on our team, except we have one, but that person could not go through all the application code and figure out like where the enums are, like where the important things are defined. And there are a lot of things defined in application code that aren't in the database, right? So just ETLing a database table over is not enough. So how do we, at scale, manage this problem? Well, Amazon Q can take all of this, the DDLs and the application code, and if we give it the right prompts, it's going to give us the join conditions. It's going to write the case statements in SQL. So now this can be delivered to a BI tool, to a data science app. So that was a spectacular thing that saved us time. And we might have never gotten this information in any other way. Kind of the list of inputs that we can provide there, the DDLs, the descriptions of the tables from the database, prior relevant SQL code. We've got sample values, the application code I mentioned. We have bespoke NLP from prior years of trying to tackle this problem, and then some documentation that goes along with it. Amazon Q itself can take up to 50,000 characters of reference material in files, right? So we set up a place where the RAG system can dump its output. Through cosine similarity scoring, it's the most relevant output for the problem. We can highlight up to 4,000 characters at the same time in the Active IDE tab. And then Amazon Q also will have a long history, right, of your chat with it. And it can go pretty far. It can keep summarizing, back in the older query aspects. Then through summarization, it just can encapsulate a lot of data and apply it. Yeah, and then we get all of these artifacts out. I would say that at this point, we're not even too disturbed if Amazon Q gets a few things wrong, because the first thing we asked for is test code. So we asked it to please give a SQL to test cardinality, grain, and null counts across all of these assertions you're making about the join conditions and things like that. And then that's easy to test. We can do that manual test, figure out that it's working correctly, and then we can accept the other aspects, like the join plan, the case statements. We can also generate ERD and documentation, which I think is important for any data-driven app, and we do, because it's so time-consuming to do manually, it's wonderful that we can get that automatically from the tool. And we've seen Amazon Q give quite good, the text output, the description output is pretty good. The ERD, obviously, it's a little ASCII thing that you probably wouldn't use, but it can also generate mermaid diagrams, things like that. And coming full circle, last but not least, we can generate the machine learning algorithms to predict trends from this data set, because it has direct exposure to the data that you need to work with. That's also a manual chore, right? To do that mental mapping of what data fields are important you're going to use in the machine learning model and create it. But that can be output here as well. So again, this turns like, what would I say, weeks, months, and years into minutes, hours, and days, and we're pretty excited about it. All right, so some recommended reading if you're interested in this topic. I got a copy of Enchi's book. Has a great section on retrieval augmented generation in it, which we're very happy to read and learn from. And then there's other sources. There's some great blog posts, and of course the Ragas metrics and things like that. So I think that concludes my talk. Thanks for listening, and yeah, any questions?
Hi, thank you so much for your presentation. It was really interesting. I just have a quick question. So a lot of examples here in this presentation are very interesting and seems like related to some, I don't know, R&D and work on a lot of data. Can you maybe speak a little bit about the cost for all these setups or frameworks that you used? And when you build something like this, do you keep that in mind, or the goal is primarily just to try and see what results from different models you will get?
Yeah, great question on the cost of these things. I think there's a couple of perspectives there. We've been working with the data warehouse for a while, so we kind of understand how to manage that cost. We have a lot of data in it. I don't think we've announced it, but you can imagine petabyte scale type, but AWS is a great vendor in the perspective of they are industry, leading on low cost for these giant solutions. So I think that the raw data itself, we have that under control. Then we look at the foundation models, and we've been doing testing. I think if you think of the billions of photos, like applying this to billions of photos and putting it in vector search and so on, I think, I guess we also haven't disclosed how we do search, but you can imagine that could be expensive. So yeah, I think, so open search on what volume, right? You probably have to plan that. I think the one thing that surprised me is running content through FMs was way cheaper than we thought in our work this summer. And I don't know if my colleague Andrew Shea is still here. I think he had to leave, but yeah, we did a lot of experiments this summer. And what you see, I think maybe one of these blogs had a mention, they're anticipating way lower costs for foundation models in the future. So now is not a bad time to be designing some AI into your systems because you can anticipate that curve is going to be there when you start to scale up. Decent price, yeah. Thanks.
Any other questions? There we go. Hello.
Oh my God.
Hello.
The cost of the use AI models inside the Amazon Web Service. Today is free, but in the future, maybe.
I'm sorry, could you use the microphone? I'm sorry.
Is for Amazon Web Service in the future start to bill monthly the service of EA?
Oh, like BI tools.
Yes.
Yeah. Yes. So we use Amazon, QuickSight, and QuickSight Q is a pretty interesting tool for that. There's a bit of a cost, but it can take a natural language query and generate a visual, which in the past had taken a lot of time. I think from the point of view of like big data warehouse, at that point you'll have pretty clean data, pretty organized data. And so I wouldn't say it's a straightforward problem, but I think they have a really good solution right now, yeah.
All right. I have a question for you then. How often would you say that Q gets schemas wrong? Like a percent?
Yeah, 40%. There's something, 40% there's something wrong.
Okay.
Yeah. But I think our approach of getting that test code first,
Yeah.
and the test code isn't hard to debug manually, and then we can go back and ask the question again, and so
Cool.
it's not perfect.
All right. Any other questions? All right. In that case, thank you to our speaker.